Welcome to Learn to Build and Build to Learn AWS IoT series. ESP32 supports capacitive touch. If you touch any touch enabled pins, then it returns a value proportional to the capacitance between the GPIO pin and the ground. For ESP32 module, the value becomes smaller when it is touched, but in case of ESP32 S2 and S3 module, it becomes larger when it is touched. Also, this value may vary based on many factors like surface area of touch, moisture in your hand, or humidity of the environment. So it is important to calibrate before you use it in your application. You can use the config function to set the sensitivity threshold at which your pin is considered as touched. Consult the spec of your module to find what all pins are touch enabled. If you try to assign any non-supported pin, it will throw value error. During hands-on, I'll show you how we can use this value error to identify all the touch enabled pins. Let's jump into Thorny IDE. I'm using generic ESP32 module. So first I'll run this small script to identify all the touch enabled pins. So what I did here, like in a loop, I'm going to assign the pin as TouchPad pin. If that is not supported, it will throw value error. Otherwise, it will print that number. So let's copy the script, paste. So I can see for ESP32 module, these are the pins which are touch enabled. And if you see in the documentation, this is also matching with the documentation. For the demo, I am going to use one of the pin, maybe 15. It's very inconvenient to touch this pin when it is already placed on the board. So to make it convenient, I'm going to use this jumper wire. One side of the jumper wire, I'm going to insert and connect with GPIO 15, clearing the shell and commenting this out. First thing we need to do is import TouchPad and pin class from machine module. Then create the TouchPad pin. In my case, pin number is 15. Now I'll call the read function to read the value. So I'm not touching the pin, it's showing 581. So let's run this thing in a loop. So I wrote a small loop to read the value in while loop. Here I am printing that touch pin reading, then calling that machine.idle because it's a tight loop followed by 100 millisecond sleep. So let's run the script. So it's printing the value. Right now I have not touched that pin. Let's enable the plotter. And here we can see the value is varying between 578 to 582 when it is not touched. Now I'm going to touch the pin slightly and value is going down. Now it's around 280 or less than 300. Now if I increase the surface area, it will be 80, 70, something like that. So without touch, it's more than 500. Light touch, it is less than 200. If I touch it completely, it is less than 80. So for calibration perspective, I can see that less than 150 or 200 is sufficient enough to identify whether the pin is touched or not. Ctrl C to break this while loop. Clear the shell. So you can use these built-in touch enabled pins in many IoT use cases to trigger something based on touch. You can also keep the ESP32 in sleep mode to extend battery life. Only if anyone touches the pin, it can wake up, send the notification or process something, and then goes back to sleep mode again. So in ESP32 module, there is a function wake on touch. You can enable by passing true, but how ESP32 will know when that pin is touched, because the value may varies from 0 to 582 in my case. That is where this config function comes into picture. Based on my calibration, I have found that if I touch that pin, the value becomes less than 200. So I can set that sensitivity threshold as 200. Then I'm putting this machine in light sleep mode. And if I touch the pin, it should wake this ESP32 module from sleep. So let's try this script. So you can see the print power saving mode. Now this ESP32 module is in light sleep mode. I'm going to touch that pin and it should wake up. Here you can see the print woke up from sleep. And you can also find out the reason for this woke up. Machine dot wake reason, and it returned value 5. Help machine, and 5 is corresponding to touchpad wake. So if you need to find out the reason programmatically, you can use wake reason function of machine module. That's all for this video. Thanks for watching. See you in the next one.